Hi, my name's Corey Glassman. I'm the Automotive Program Manager for Fluke Corporation. I have with me today one of the most advanced digital multimeters in the world, and we're going to put it to the test, on car, on the bench. I've also brought some other meters that I think you'll really be interested in, along with some accessories that'll help extend their capabilities. Perhaps the most important tool you have in the shop today is your digital multimeter. All of these instruments have a lot in common. They all measure volts DC, volts AC, resistance and diode test, and even current. Some of them, however, have some advanced capabilities such as temperature, also frequency, duty cycle, pulse width, and even RPM. Now, I've also brought along some accessories that'll enhance the capability of your DMM purchase, such as external current. We also have a wide selection of test probes and leads that allow you to get better access to the signals. The DMM is divided into several different areas. First, you have the input jacks located at the bottom. They're color-coded, red being positive and black being negative or common or ground. On the left side, you have your current measurements. That would be internal to the meter, 10 amps continuous or 20 amps for about 30 seconds. Now, these are special fast blow fuses. Why? It's because you want to disconnect yourself from any high current circuit. Well, what about measuring on hybrids? You know, you're pumping out a lot of voltage and current out of a hybrid. And if you're connected up to that circuit and something goes wrong and it goes phase to phase or phase to ground, blows the circuit, you want to make sure that it separates it immediately. Next, you have your rotary knob. The rotary knob controls the basic functions of the meter. In other words, what do you want to measure? Volts AC, volts DC, millivolts, resistance, diode function, or current. Perhaps even temperature. And you can access those by just simply rotating the knob. Next, you have these push buttons on many of the different instruments. These push buttons enhance the capability of the instrument. How? They have a digital recorder built inside called min-max. We have another function called relative or zero, which actually subtracts one measurement from the next, and we'll show you on car how that can be really handy. Next, we also have frequency, duty cycle, and even some touch hold functions. Finally, you need to look at the display. The display has an analog bar graph on most of the instruments, as well as a digital display that'll indicate exactly what you're measuring. It's a good idea when we're running tests on a vehicle to baseline. Baselining is where we test the battery voltage, we look for voltage drops, we check physical connections. We also look at the charging voltage in the vehicle and charging current to make sure everything is normal before we dive into diagnostics. This is a basic drawing of what we're going to test next. There are several points that we're going to measure. First, from the negative post of the battery to the engine ground. We're going to measure from the negative post of the battery to the body ground. Next, we're going to measure from the positive post of the battery to the output bat terminal of the alternator. And then finally, you can measure the ground side of the alternator, which would be test point number 4, to the engine ground. Now remember, with the engine not running, the battery is your source of power. With the engine running, your battery becomes a load and is actually recharged from the alternator, which becomes the source. We'll start by connecting the black lead up to the negative post of the battery and the red lead up to the positive post. We'll then turn the meter to volts DC and engage the min-max function. You can see we have a surface charge of 12.25 volts. That's pretty good. Now, I did turn on the headlights when I drove the vehicle in to bleed off some of that surface charge. So now what we're going to do is start the engine and shut it off and take a look at what type of voltage the starter is using and what's going back to the battery from the alternator. This is the present charge of the battery. It's at 12.24 volts. If I push the min-max button again, 14.04 volts. That was the amount of voltage that the alternator was putting back into the battery. If I push it one more time, it goes to minimum, and that's 10.24 volts. That's the voltage drop from the starter. That was the amount of voltage required to get this thing cranking over. As long as it doesn't go below 9.5 volts, I'm okay. The next function I want to show you is called relative. It's also called zero on some of the meters. Now it really doesn't zero the display, even though you'll see that the digital display will go to zero. The analog bar graph right down here at the bottom will still show the actual voltage. If I hit relative right now and I'm hooked up to the battery, it shows zero. What I've done is I've taken a reading of the battery and now I'm subtracting it from all future readings. So it shows zero, but when I start it and run the engine, we'll just see what the alternator is putting back into the battery. As you can see, we're putting in 1.6 volts back into the battery while the engine's running. In this test, we'll take a look at some voltage drops. A voltage drop is excessive resistance in any one of the connections. Now you can see I've configured the meter to measure millivolts. You'll see a little bit of digit rattle. That's normal because we're measuring such a small amount of voltage. Now we'll take the black lead and we'll hook up to the negative post of the battery. Then we'll take the red lead and we'll put it on a good ground on the engine. Next we'll engage min-max. Now we'll push the min-max button and we'll see what our voltage drop is. 0.4 of a volt. Now we'll take that red lead and we'll switch over to the body, a good body ground, and we'll run the test again. Now we'll push the min-max button again, and you can see that we're only down to 36.3 millivolt drop. That's a lot better. Well, we're going to run this test again, and you've caught me. I brought out my big bag of tricks, and this is a test lead assortment that we have. It has a lot of different clips and adapters. If you don't have one of these, you should get one because it makes your job so much easier when you're accessing some of these test points. Now in this case, we'll measure the voltage drop on the positive side of the battery system. Now here we'll take the black lead and hook around the red post, and we'll take the red lead. Now you see I've selected a long reach alligator clip and it's all insulated so it won't short out on the back of the alternator. I'll connect, I'll hit min-max, and we'll run the test again. Now we'll push the min-max button to see what the drop is. 233 millivolts. That's only 0.2 of a volt. That's not bad. In this next test, we'll look at AC ripple voltage. AC ripple voltage is unwanted AC voltage that leaves the alternator. It sneaks past the rectifier bridge and the diode trio and it gets to the battery. Batteries don't like AC. They only like DC. So any AC that they get, it sort of discharges them. Now we'll make this test with the same connections on the back of the alternator, and we'll switch the black lead to the negative post of the battery. But instead of volts DC, we'll switch it over to volts AC and run the test. With the engine running, we should see no more than 500 millivolts. Here we have only about 50 millivolts. That's not bad. Now I'll raise the engine RPM up to about 2,000 to 2,500 RPM. That's typically the point where we'll see problems occur. In this case, pass the test. As I mentioned to you before, the meter will only measure up to 10 amps continuous or 20 amps for 30 seconds. That's not enough current to go ahead and measure the output of the alternator, or definitely the starter. For that, we need to use one of these current clamps. This current clamp measures the magnetic field around the wires as current passes through them. And it will convert that into a voltage reading that the meter can pick up on, giving us the current. I've connected the clamp right over here into the input jacks of the meter. We'll configure the meter to read volts DC. Next, I'll push the green button on the clamp. It turns on the little LED indicator light saying we have power. Now this clamp has a little arrow right over here on the top, indicates the direction of current flow. So I'll connect it around the negative posts, all of the cables. We'll engage min-max, and we'll crank the engine. Now we'll push the min-max button, and let's take a look at what type of current draw that we had. We actually dropped it 400 amps. 407 amps is what this starter is pulling from that battery. In this case, I've moved my clamp from my negative post of the battery. I've put it around the one red lead that comes off the back terminal on the back of the alternator. You can see I'm measuring 46 amps coming back out. One of the great things about the Fluke 88.5 is its ability to measure millisecond pulse width. Now, millisecond pulse width is very similar to duty cycle, which gives you a percentage, but millisecond pulse width actually gives you time in milliseconds. It's used for some of the different solenoids we find on the vehicle, as well as fuel injectors. Now, in a fuel injector, the pintle pulls away from the seat and injects fuel into the engine. We measure that with milliseconds. To configure the instrument, we go to volts DC. We'll then push the frequency button 3 times. That's where millisecond pulse width is found. We'll ground the black lead on the negative post of the battery, and the red lead will use a special back probe pin that gets past the weather pack seal to the injector. We'll go on the ground side of the injector. I've hooked my black lead up to the negative post of the battery. I'm set to volts DC. I'll push the frequency button 3 different times until it reads millisecond pulse width on the display. Now I'm using a pretty neat little flexible back probe pin. This will allow me access to the signal past the weather pack seal. I connect into my flexible test leads. And we have the millisecond pulse width measurement. You can see if I rev the engine, I'll get enrichment and enleanment. Another one of my favorite adapters is the PV350. Pressure vacuum module, and it has a transducer that's remotely mounted so you're not taking fluids or anything into the vehicle on a road test or anywhere else. Let me show you how it works. We take the meter, we plug the module into the volts and common input right down here at the bottom. We turn it to millivolts input. With the instrument off, if it measures above 100 millivolts, it's testing the internal battery. Means it's good. We switch it to either inches of vacuum or PSI, and we tell it if we want it in English or metric. Now we simply hook up, start the car, read the vacuum. Do you ever wonder what temperature it is? Not only in the building here, which is only 56 degrees, so it's a little bit cold. But what about on the engine? What about in an air conditioning duct where I'm trying to measure plenum temperature? Or in a radiator? Or even the actual temperature of the coolant? I can now measure that with this flexible bead probe that comes with a lot of our meters. All you do, simply plug it right over here in the bottom of the meter into the input jacks. Turn the meter to the little temperature symbol and configure it to measure temperature. Let's take a look. You know, something else we face all the time is parasitic drain. You know, the small amount of current that keeps robbing our battery from its power. So if a car is left over an extended period of time, you come back out, battery's dead, right? I-30 current clamp. It's a low current clamp. It works beautifully. Let me show you. Something to keep in mind when you're working with low current clamps. You're talking about a very small amount of current. All the current passes through this small little jaw opening. This can become magnetized over time. To degauss it or demagnetize it, simply snap the jaw a couple times. Now be careful not to wrap it or drop it, as you could damage the cores. That is possible. Also, when you're adjusting the zero on this, Earth's magnetic field from moving it around could affect the readings. We've plugged it in right over here. We'll turn the meter to millivolts, and you can see we have 23, 24 millivolts. You can see by moving it around, it does affect it. So we'll parallel the load best as possible. We'll adjust the clamp right over here on this zero knob by pushing down and rotating it slightly. You can see how it's moving back down towards zero. Once we get it as close as we can, we simply connect the clamp around both conductors leading from the battery. You'll note you have one primary conductor out of the battery here, and then you have another one that goes to the body of the vehicle. Make sure you're around both of those. Now right now we're reading the 23.6 millivolts. Let's take a look at what happens once we turn the key on. As I turn the key on, you'll hear the fan start to run inside the vehicle. Now that's about 10 amps, more than what this range of the meter can handle. So you'll see the meter go to OL. If the meter does go to OL, all you need to do is switch it to DC. The moment you go to DC, we could read 14 amps, 15 amps. You can see as the current changes on the face of the meter, you could read exactly what current is being drawn out of the battery. Now I'm going to turn off the ignition again and go back to milliamps or millivolts on the meter. You can see we're at about 80 millivolts, which also stands for 80 milliamps on this clamp. That's our parasitic drain right now. And as the PCM starts to shut down different components, you'll start to see this current level drop over time. That's not bad. The battery's not going to go dead with a reading like that. When we started this video, I was going to tell you about some of my secret tools. This is one of those. It's one of my favorites. This is a piercing probe. Now I know what people think about piercing, but getting access to some of these signals isn't easy. Now when you do use a piercing probe, the nice part about this one is you control the amount of penetration by rotating this little thimble on the end. Sends a pin into the wire through the insulation, but it's a very, very micro fine pin. When you're done using it, it's important to remember to reestablish that weather seal, that weather-tight seal. So instead of using RTV, some folks just take a little bit of RTV and put it on the insulation, but RTV absorbs moisture. That's how it cures. When it does, it forms acetic acid. Acetic acid is sort of that blue stuff that you see on wires quite a lot. Right? You want to stay away from RTV. Usually what I'll recommend is either some clear nail polish or a little liquid electrical tape. Even a little WD-40 can seal up a lot of the wires. But I'll tell you, this probe is nice because the pierce is so very fine, you hardly notice it. So we're going to hook up to the TPS, to a throttle position sensor. On this vehicle, 0 to 5 volt bus. It varies the signal to the PCM, which in turn lets it know how far the throttle is open. We're going to go ahead and sweep the throttle. We'll go to wide open, and then we'll go back down to closed throttle, and you can see how fast it is in responding. Another thing we can do is engage min-max as we did before. If we're concerned that there's any dropout in here, we can sweep the throttle and bring it back down, and we could take a look at what the readings are. Even gives us an average. All test leads have some type of resistance, and that's normal. Now, as they age, that resistance might even go up. When making measurements, especially using the resistance mode, and you're looking at a very, very fine measurement on an injector coil or a small coil in a relay, you need to subtract that test lead resistance. Let me show you how you can use that zero or relative mode to subtract it out. I've configured this meter to measure resistance and plug the test leads into the input jacks. Next, I'll short out the test leads. You'll see that we have about 0.2 of an ohm of resistance. If I push the relative button, it subtracts that test lead resistance from all future readings. Now, I'll connect it up to my fuel injector. There you have it, 14.3 ohms. If I didn't subtract out that test lead resistance, it would be a couple tenths of an ohm higher. In this case, it may not be enough to go out of spec. However, some fuel injectors and some low resistance coils have such tight tolerance that even the test lead resistance could cause it to go out and show bad. Another one of my favorite tools is this guy. It's called the RLD2. Looks like a standard flashlight. In fact, when I configure it, it comes on, pretty bright, looks like a standard flashlight. But it's pretty unique, also for leak detection. We've all used this fluid before. You add it to the oil, you add it to the water, and then you fluoresce the fluid, excite it, and look for where the leak's coming from. Well, now with the RLD2, this is so bright that it's going to find the leak for you. Very fast, very efficient. All you do is add the fluid and then fluoresce it. Here's a great feature you need to be aware of on many of the Fluke meters. It's called Auto Hold, located right over here on the upper right. You can see I'll make the measurement on this battery. It's 1.6 volts. Take the test leads away, well, the display goes to 0. What if I'm under the dash trying to make a measurement and I can't watch that display? Well, engage Auto Hold. Now, simply touch the circuit, make the measurement, take the test leads away, and it freezes it. Even though these meters are auto-ranging, many times they start up in a manual range, depending upon the measurement we're trying to make. I've connected up to the extension cord. I'll turn it to measure volts AC. The meter is reading OL. Why? Well, it's because it manually ranged to 6 volts. Because around a vehicle, we want to measure the AC ripple voltage out of an alternator, and that's typically no more than 0.5 volt. I'll push the range button for a couple seconds. It goes to auto range, and it found the voltage. Next, if I want to look at the frequency, I push the button one time. There you have it, there's 60 Hertz. Push it again, and I'll measure the duty cycle, 50.6%. Another tool I really like, especially when I'm working around the shop, or if I'm working on delicate electronics, or in the paint booth. It's called the 971. The 971 is a relative humidity meter. So it's going to give me an indication of both temperature and relative humidity with a push of a single button. You know, if our job wasn't hard enough, but part of it is when you're making a measurement with a meter, how do you position the meter so you could see it either under the dash, under the hood, or under the vehicle? Let's say I'm connecting up to an oxygen sensor and I want to look at the display. Well, sometimes that's tough to do. Not anymore. What we've come up with is a magnet on a strap that connects to the back of the instruments. Now I can position it exactly where I need it and have the best visibility. I've saved one of my favorite meters for last. Fairly new to the Fluke line, just out. We've been working on this for quite a while. You know, if you're working by yourself in a shop, sometimes it's difficult if you're trying to make a measurement in the rear of the vehicle, let's say at the fuel pump or brake lights or something like this, and you're working under the dash. How do you get that measurement? Or you're on a road test and you want to make a measurement under the hood or under the vehicle and take it with you on the road test. Well, now you can. The Fluke 233 Automotive multimeter. Let me show you. I can configure the meter. Looks like a standard meter. It has volts AC, volts DC, resistance, even does temperature and current. Now I can separate the two. Here's the base unit, here's the remote. I can take the remote with me into the car and I can make the measurement on the back or underneath very easily. Let's take a look. Here we are at the rear of the vehicle. You can see that I've accessed the brake wires for the brake lights. And we'll just take a look. I've used one of the piercing probes to actually get the signal, which works pretty well because once it gets the signal, it's completely isolated. Now I've hooked up the meter. We'll put it to volts DC. I'll separate the head and I'll meet you up under the dash. What's neat about this is now I can get the reading. I step on the brake and I've got instantaneous measurement of what's happening in the rear of the vehicle. And I'm just by myself. The Fluke 233 Automotive has the ability to measure over 30 feet away from the base unit. And they've even put a rare earth magnet in the back of the head so you can put the reading right where you need it. Fluke makes some great equipment. You never know how they're going to be treated in a shop. Now, I wouldn't do that with my cell phone, but I have all the confidence in the world to do that with a Fluke instrument because they work. Well, this brings us to the end of this presentation. I hope you've enjoyed it. With Fluke, you're using some of the finest tools in the world. Your imagination is your only limitation when using them. If you have any questions for us, please give us a call, 1-800-44-FLUKE.